And welcome, function folks. This is a lesson on inverses. The first thing we're going to take care of, though, is a bit of business from last night's homework. You were asked to fill out this sheet, um, which is the final word on transformations. By the way, it's not the final word on transformations. We'll do transformations at least 3 or 4 more times during the semester, but this was sort of a investigation about the order of operations. If you have not tried this, do not watch this video. It'll spoil the discovery and all the fun that goes with that. So I'm going to go through this fairly quickly now. You see my answers right there in front of you. But if you haven't tried this, you should try it on your own, please and thank you. Okay, in example one, we're given the absolute value function, which is this blue one here, and we're asked to compress the graph of f horizontally by a factor of 0.5. Compressing horizontally, opposite that, you'd think x becomes 2x, and there's a 2 in with the x. So that's the equation of this green one, and you can see each of my horizontal distances were cut in half. Where I had a point here, it got cut in half. Dandy. And then the second part, I want to move the graph from A to the left 6 units. So I'm taking this green one and I'm moving left 6 units. What's the new equation? Well, I graphed it, but what's the new equation? The x becomes x plus 6. So the x becomes x plus 6, and I can see there ends up being a bracket in there. And just in passing, this is the way that we would normally do this, right? We do the compression first and then the move to the left 6 after that. This is what we're used to. Now, the second example are the same, excuse me, the same transformations, but applied in the opposite order. And so what happens is we move to the left 6, and we end up with this red one with the original shape of the first blue one there. And then what happens is a little bit strange. Compress the graph from A horizontally by a factor of 0.5. So all of these horizontal distances get cut in half, right? So where the starting point was there at -6, it moves to -3. Where it was, this point was at 5, it moves to 2.5, and so on. All of the horizontal distances get cut in half. And so what's happened is some of our move to the left on the first step got cut in half. And notice the difference in equation there, where the second thing was to cut it in half, the x became 2x, right? So the x became 2x. And you see that this isn't quite the same thing. And they shouldn't be, because they're not the same graphs. We see this green graph, which was the end one from the first example, is in a different position as the red one from the second example. So they are different. And we're used to seeing these brackets. And in fact, I could have factored out the 2, and then I see the more familiar version is the stretch and move with the brackets. So there's the conclusion right here. When we do 2 transformations in the same direction, especially horizontally, that's the important part, in the direction of x, order is important. So in factored form, we do compressions and expressions first, like we are used to. So if we see this, we have to factor out the 2. Or we have to worry about the order. We're used to doing the compressions and expansions first. And then the second, what is the second example? No, third example. The third example is for you to do the same graph twice. So notice that in the direction of x, we don't have any brackets. It's not in factored form. So if we factor it, then we can clearly see the horizontal squish and the move to the right. And where was my original graph? Was this black one. And when it's in factored form, I can do my horizontal squish first, like I'm used to, and all of the horizontal distances get squished by a factor of 3, right, or 1/3 rather. And so that's this red graph is the square root of 3 times t. And then I move this red graph right 2 spots to get this green graph. And then in example 4, they want you to do the exact same thing, but in a different way. Well, what would be the different way? Well, that would be not factoring. That would be doing it in the opposite order that we think. So in the opposite order that we think, we'd move this graph right 6. So this is the black graph moved right 6, and then horizontally squished by a factor of 1/3. And so here, 1/3, that should actually be back at 2. That one, I don't know if I can grab it. Can I grab that one? Yep, there it is. Move it back. Starts at 6, gets horizontally squished back to 2. Everything gets moved, squished back by a factor of 1/3, and then I get that green graph, and these are actually the same way. So the moral of this story is we're going to usually do it this way, where we factor out the 3, and then this is more familiar feeling than having to move all the way to the right 6 and then squish back some. This is probably less simple for us, less straightforward, but it still works if you prefer that stuff. All right, on to today's lesson. Today's lesson is on inverses. This is the 3-minute review, which is now more like a 10-minute review. But an inverse, remember, is the opposite operation. An inverse undoes what a function does. Okay, and there's this little video, which is kind of a helper video for me. You can watch this one, and then I'll summarize what this said in a second. So I'm going to stop the first part of the video. The second part is you watching this video, and then come back for the third part, which is me continuing on with the lesson. Okay, so I'm going to stop there. You watch that video, then come back for me again, part 3.